Hello, my name is Bradley Alicea, and I'm going to talk to you today about the project management course I designed. So, this is project management from an open perspective. So, this is the traditional project management course that people typically associate with the topic, involving things like agile processes and managing groups of people, working groups. But we also approach this from a perspective of working open, or the way that most people are familiar with it is open source software or open source software teams, or we actually do expand this a lot, as you'll see in the course. And so this has been taught at the University of Illinois iSchool as IS 340. This is also used in the Orthogonal Research and Education Lab as part of our open source ed project. And so all content is CC BY. So in this class, we'll learn about a lot of things. We'll learn about open access publishing, technical debt, agile methodology, Kanban boards, copyleft licensing, version control, project roadmaps, issue management, automation techniques, distributed collaboration tools, community data analysis and evaluation, the history of project management, working open, project sustainability, project scoping, 501c3 foundations, technical documentation, discussion forums, community development, and project complexity. Taken just kind of in isolation, all these maybe don't make a lot of sense, but they're integrated into a curriculum of 6 units. And we cover a lot of other topics, but I'm just giving a smattering as an example of what we cover. So the full 16-week term, and this is also taught in the summer as a condensed 8-week term, or an 8-week version. But the full 16-week term, as well as the 8-week term, has 6 units. Unit 1 is called Working Open, and that has an emphasis on the principles and the practices of working open, or working in distributed collaborative groups where you build open source things or open access things or open whatever you want to call it. We'll talk about that later. The second is community building. So a lot of open source software projects have communities where people contribute freely to the project. You may also have a community of customers or a community of users. You can think of that as a community as well. And one of the things you need to do to maintain that community is to build it. So you need to go find people who want to be in your community. It could be a bunch of super users. It could be a bunch of people who want to contribute to the project in different ways, and so forth. Unit 3 involves discussions, documentation, and public events. So it goes from this community building more generally to the elements of community building. So to build a community, you need to discuss things, you need to have discussion forums, you need to host discussions on various topics. You need to document your processes and document your project, so you need to build documentation. And then you need to have public events where you can showcase things, have meetings, public meetings, be transparent about things. And those will help you innovate and build your community. Unit 4 involves project scope and types of contribution. So we talk about how to scope a project, how to make it the right size, how to make your objectives the right size to actually complete them. And then going from the side of the community, you want to have different types of contribution that are suitable for people's skill sets and people's interests and people's domain knowledge, so that you can get things done in a timely manner. Unit 5 is project lifecycle and sustainability. So moving on from that, we need to think about project lifecycle. Like, how does the project evolve over time? What kinds of, maybe there's a beginning to your project and an end to your project. Maybe you have different releases that you want to make. How to schedule that and make that work. And then sustainability, which is maintaining the project over long periods of time. So maybe you have a project where the first 6 months were great, and then you have no plan for sustainability, so you fall back, where the project atrophies and dies. We don't want that. We want to help you keep your project sustainable. Sometimes that involves a lot of support. Sometimes that involves building and maintaining a community. Sometimes that involves licensing issues, as we'll see. Unit 6 then is the final unit, and it focuses on funding economics and commercialization. And I included this unit as a way to kind of give people hope that they can actually make money off of their projects, but also that, there is this sort of, um, you know, entrepreneurship or this innovation aspect to it where, there's a lot of support in a campus community. For example, we have a commercialization office and we have an innovation hub. All those places can help people realize their projects and drive them forward. You have to be able to fund your project to make it work. You need to understand the economics of the area that you want to build a project in, those sorts of things. So I'm going to go over some of the topics that we covered, and they're kind of the slides from those units. So aside from those units, we have different topics, and they intersect in the following ways. So the first is technical debt. And this is kind of like to impart the idea of technical debt. I gathered a couple of memes on technical debt from the software development community. And, this first one, it talks about developers having these mundane tasks such as bug fixes and refactoring and being distracted by new features. The idea being is that you need to focus on your bug fixes and refactoring before you go for your new features. A similar thing in the center where a product manager sees a new feature and the monster of technical debt pulls them back from it. Then the third one has Fry from Futurama. Not sure if refactoring made code more understandable or I just understand the code better because I spent hours in it. So this intersects with a couple things we stress in the class. One is that you have, as your project evolves, as it's to make your project sustainable, you have necessarily a certain amount of technical debt. As times change, as technologies change, that technical debt is built into your project. The key is how you manage it. Sometimes that's focusing on things that you need to fix before you start something new. Sometimes it's communicating the ideas behind your project to new people. And so this is why I cover these things, and I talk about this in the class. Another thing is a timely topic, generative AI, and how that intersects. That kind of a project shows some of the aspects of building an open project and how licensing in particular can play a role in managing what you do. So this is an example from generative AI. Generative AI is built on training models on data from different sources, and they have forks of their projects where people build different versions and train them on even different data. So they're generating all these new things. And so one of the key things about generative AI is licensing. If you take training data, do you have the permissions to do that? And then does your license cover what's produced by the algorithms and by the people forking your repositories? And so this actually helps people think more broadly about some projects that may not fall neatly into some of the areas we talk about. So sometimes your project will build upon something that's proprietary. Sometimes something proprietary will build upon an open source project. What are the licensing conditions? These are things that you need to think about, not only in open source projects, but in project management more generally, to make sure that you're able to continue your project and see success. Another topic that's also very timely for the instance that's been taught at the iSchool is project management strategies for open data. So there are a lot of students in the iSchool who do open data, or they do data science, and I think they have a strong interest in open data because a lot of them are working with data sets that they're getting off the internet. And so this unit talks about open data as being this, openly accessible, exploitable, editable, and shared by anyone for any purpose. Open data is licensed under an open license. So this is where you have data sets online that we don't just throw data sets up. We don't just take data sets to use without considering their provenance, their quality, the privacy and security issues that come sometimes with projects like health related projects. There are a lot of security issues you need to worry about. And of course, there are open data standards that people have to be aware of. So their projects may intersect with open data, and we teach them about that in the course. Then there's this whole issue of sort of innovative tools we can use to guide community building. And one of those is called the guidance tree. And this allows us to sort of optimize the aptitudes of our contributors. And so this comes out of the community committee at Open Worm Foundation. Stephen Larson, pictured here, in about 2016, proposed that we build this sort of sorting hat, as he called it, for people to figure out where they fit into the organization. One common problem in a lot of open source organizations is that you get a lot of people who come in and they're interested and they kind of get onboarded and then they don't know what to do and they go away because they don't really have anything to do. So this is a way to kind of focus that talent, focus that aptitude into different things and make it very explicit what you need to do, how you do it, but based on like what you really want to do or your aptitudes, your interests, and so forth. So I implemented a version of this in the Rockwire community when I was there. And it starts very simply. It starts with a binary choice. Are you interested in coding or what we call building, which was, building documentation or design or other things like that? And so those two categories then are broken down further into different, projects that are going on, and then it gives links to different resources where people can get started with what they're interested in. So this is an area that I've been working on. We have releases of these guidance trees under CC BY license, and so as you'll see later, some of the students really enjoyed this topic. So we teach them these sorts of practical things as well. And then finally, there's this issue of issue scoping, and this has to do with scoping projects, but also making issues. And as you'll see, Quiz 2 will involve creating issues on an issue board. So they're going to be doing this issue scoping. So you break things down into things to do, certain issues. I want to do this thing by a certain date, and then you put them together. And so sometimes in a project, you'll have a bunch of issues on a board and you'll review them and you'll try to get issues done as needed. Sometimes you'll prioritize some issues over others, but the scope is important. So you're not trying to do everything at once, or you do something that's so trivial it doesn't do anything for anyone. And so the way I did this is I introduced these different types of shots. There's an Earth shot, a Moon shot, and a Mars-Jupiter shot. And this is showing the Mars-Jupiter shot. So an Earth shot is where you're just kind of traveling on the surface of the Earth. You're just, addressing maybe a single issue or a very simple thing. Like in a lot of communities, they have good first issues where it's a very trivial thing that you do. And it's mainly for just getting acquainted with the community. So it's very simple and the scope is very easy to define. The moonshot is, of course, based on the real moonshot where we tried to get to the moon, bootstrap getting to the moon on a rocket and getting people back to Earth. That process, that was a very difficult problem at the time and involved a lot of interrelated issues that needed to be solved in real time. So, you'll have a bunch of issues that have to be kind of related to one another. A Mars-Jupiter shot is even more complex than that. And it's a problem that cannot be broken down into multiple issues. So you might have a moonshot that you're working on, but then you have another moonshot on top of that. So you're basically trying to get from Earth to the moon, moon to Mars, and Mars to Jupiter. And you're doing all of this as a set of interrelated moonshots. Sometimes you have to link issues that are not yet defined. So you have to figure out new issues from old issues. And, as problems come up, you need to solve those with new issues or break down old issues to get around bottlenecks and things like that. But crucially, in a Mars-Jupiter shot, these are multiple dependencies that you get from some of these moonshots. So once you build a moonshot, so you build an application, and then you want to build another application on top of that. There are a lot of dependencies that first application will introduce that then you have to plan for. So it's just really introducing levels of complexity. And in fact, we have a lecture on project complexity that's separate from this, but I think it frames the context very well. So there's a very strong component of understanding project complexity in the course. So then at the end of unit 1, I introduced this concept of open source, open access, open XYZ. And so what I mean by that is you can make anything into an open source project. We talk about open source software, but I try to make the course software centric. I try to make it broadly applicable. And indeed, the students in the iSchool are interested in technology, but they're also interested in other areas that they can apply this to. A lot of their projects were based on technology. Some of them weren't. But I want to make this very broad and sort of as broad as possible, so that you understand that this is an ethos more than just kind of related to software design. So there are all sorts of things that people have made applied open principles to. So there's open source hardware, which is creating hardware that anyone can get the plans to and build their own version and modify it. There's open access publishing, which is where you have published works that are open access. Sometimes those are licensed under a Creative Commons license, so you can remix the figures, you can use them for your own needs. You have open source software where the code is available and you can remix the code or modify it as needed. You have open data where data sets are open according to certain standards and certain procedures. You have open government where governmental procedures and laws are open to a certain extent, where you can, they're transparent, there's openness. There's open journalism where people can report, they can open source reporting. There's open courseware, which is educational based, and open science, which is where you have open and transparent protocols. So I want to make this really broad. I want people to understand that this isn't just about software. So the first activity to do in the course is quiz number 1. And that's version control using GitHub and Markdown. So I introduced them to the world of Markdown, which is a markup language that basically allows you to format text and introduce figures and things into a document that you can host on GitHub. The reason I introduced Markdown is because it's often used in README files and other materials in version control systems in open source projects. But it really is a way for people to get experience with programming, with thinking about different programming tasks without really having a lot of experience. There's a prerequisite that you have to be familiar with programming, but I don't want people, to be hindered by maybe a lack of knowledge of any specific language. So we use Markdown as a good example of that. And then we introduce people to GitHub using GitHub's version of version control and the processes behind reviewing files and updating files and things like that using GitHub. So they get 2 tutorials, one on GitHub and version control, one on Markdown. And then they have to do their first assignment, which is this quiz. And this is quiz 1. So quiz 1 was consisted of 2 parts. The first part was to open a name file. Actually, the first thing they had to do was to fork this repository on their own GitHub account. And so then they had a working copy there. Then they would go into this name file, which then they would enter their name in according to a Markdown template. They would commit that, and then they would issue a pull request to have that accepted into the URL group GitHub organization. The other part of the assignment was to create a document according to a template. They had to introduce 3 elements in Markdown or in HTML, combining Markdown and HTML. There were a number of nice examples that people did in the course. We have them all archived in this repository under quiz 1. So the first one I want to cover was Alicea Gilly. She did one on Valentine's Day because the assignment was right around Valentine's Day. This is just kind of going over some of the text, formatting text in different ways, introducing a list, and then a figure or an image, putting it into the file. And so if you look at the raw code, you can see that there are a couple of elements here. They're in Markdown, one's in HTML. And so that teaches them how to build a basic document. Another example was from Ethan Wee. And Ethan is interested in interested in surfing. So he did this thing where he actually did a national parks guide where he had an image of one of the national parks, and he did distance in miles and the fare calculation. He just had a table. This is just like, lorem ipsum, basically. Just plug in things that may not be thematic but are interesting. So I just wanted people to get an appreciation for the coding elements rather than any sort of stylistic thing. So then they had a practice session, and this was actually 2 classes right around spring break during spring term, and we'll probably do this in the fall. The summer course won't have this luxury, but it's basically a set of practice sessions where they basically talk in groups and then come up with their projects, and they talk about what they're interested in, and then we talk about collectively what kinds of principles can be applied to these projects. So this is a brainstorming session where we talked about the how and the why of their project. So there are actually some really good ideas at this point in the course, which is about halfway through. They talked about, there was one where there was an app for surf conditions, which involves getting data from weather stations, getting data from individuals who are observing the surf conditions, and then bringing that all together in an open source application. So there are a lot of elements of open data, community building, and other types of things that you might need to do for developing an app such as this. There was another one on bringing restaurants together to assess excess food availability. So when a restaurant has too much food, instead of throwing it in the garbage, they can communicate with like a nonprofit to take that food and reuse it. And so that requires you to have data from different restaurants, a community of restaurant owners or restaurant workers, and a community of nonprofits to sort of interact there. And so there are a lot of principles that can be applied to that as well. There was also a healthcare app that monitored chronic illness trends. So this is where you get into this open data again with the issues around privacy and accessibility. And so there's a lot of principles that can be applied to these projects. And so we talked about how to do that in this session. On the right, I gave them an example of a roadmap using a project that I kind of worked out on the fly. This is where we talked about building some hardware for a certain purpose, for driving a VR headset, I believe. But what the point of this was is to look at like a roadmap in terms of different milestones, 6 months, 2 years, 5 years, and then to consider what happens when technologies change or when social conditions come about where it shifts your goals. And so in this case, we had FPGA devices, maybe they became scarce during the pandemic, or our contributors changed their focus during the pandemic. And so, I use the pandemic as kind of a tie point here, but it could be anything that happens. People's lives change, technology changes, etc. And so just to illustrate that to the students. So that was practical, and then quiz 2 was another practical where we talked about issue management using GitHub projects. So we created these issues, we put them on a project board on GitHub, and we did this collectively. So we had a single project board for the class. I had them design 5 or 6 issues for their projects that they proposed in the practical, and then they put those on the board. So this is what the board looked like. This is everyone's project, everyone's set of issues. I basically, we set up a board. I set up a board where they had I think 5 categories, and the students actually added a couple categories. And I pulled it up in class a couple times to go through it, so that as we were doing the assignment, we could see, what the management. There were 2 parts of this. One was that it taught the students how to build these issues, how to choose the right scope, and to put them in the right category. So whether it was something you need to put in to do, or on hold, or in progress, or urgent, or so forth, whatever category you want to put it in, and then having the right scope, something achievable, something just about the right size, and then in sort of in the right time frame. So is this something that's a future thing or something that can be done within maybe a month? And so the other lesson was is that me as the community manager of the board, I wanted to show them how all this works, how if I'm the maintainer or the manager of this board, how all my people being assigned to different things, how I need to like make sure that if glitches happen, which happened actually in quiz one as well, how those get mediated. And so I can actually show them in real time how that all works in a GitHub environment. There are other tools to do version control and project boards, but I wanted to focus on GitHub just to stay in the same environment and give them an appreciation for a single platform. If they want to run their project on another platform, that's perfectly okay. But I wanted to give them a taste of this sort of process. And then what they also did, going back to quiz one, was they took the skills they learned in quiz one and the skills they learned in quiz two and applied it to submitting their final paper. So they submitted a version of their final paper to me in PDF format, and I graded that. But also they needed to submit a final paper using the practical skills learned in the quizzes. And so there's a repository of papers now. Their final papers are all here. It required them to take a template they had a fork already of this repository, so they needed to refresh the fork. They needed to learn how to do that. Then they needed to take the template and add to the template their paper, plug it into all the parts of the template. And I tried to make it easy to follow through. And so one of the glitches we had here was that people kept overwriting the template unwittingly. And so we had to kind of have a discussion about, actually, it was a nice opportunity to show them how to restore the history of a file. So you could go back in the history button here above the files on the right and go back and look for a certain file and restore it. And sometimes this happens in real projects where things get deleted, and that's the benefit of having a version control system is you can do things like that. So it was a learning opportunity. Definitely worked out. I think they got a lot out of these exercises. So I wanted to provide examples of applications that our students from Spring 2023 did. These are their final projects. They did a short presentation on it, then they did the paper. And so one of I think the things that really resonated with students was this idea of guidance trees. Tyler Falls and Dara Prashad both provided examples of guidance trees, and these are different from the ones that I showed in class. So I think they did a good job of like kind of translating this principle into practice. Basically, it starts the same way. You have this binary decision. Do you know how to program? Yes or no? And then do you want to create code or debug? And then you have this, choice. So this was a simpler one than this one. But one of the things I taught them in conjunction with guidance trees was this idea of controlled vocabulary. And so Wikipedia uses these a lot. And the idea of a controlled vocabulary is where you have a certain set of terms that everyone agrees to the meaning of. So you say, what does it mean to code or debug? Or what does it mean to, program? So everyone who comes into the community can refer back to this controlled vocabulary. When they do something like this, or when they talk to people about an issue or whatever, they have a common terminology that everyone knows the meaning of. And so this is useful in these guidance trees because you're starting with a reference point. And in order to get a reliable answer, so people know which path to choose, they have to know what you mean by a certain thing. So when you say, do you want to create code or debug? Debugging has a certain definition. Creating code is a certain definition in the context of your community. So it's important to couple those controlled vocabularies with the guidance tree. And I think both students did a good job on that. The second highlight here is Ria Shah, and she created a Gantt chart. So this is a Gantt chart of the 3 different phases of her project. She did a very good job of setting up it. So it looks like a roadmap in issue form. So you have the different phases of the project, the different tasks or issues, and then the weeks needed to complete it. So at least this gives you a good idea of where to start. Now, if you put this on an issue board, it would be very easy to put on, first of all. But secondly, then you could rescope as needed or to adjust the schedule as needed. So this really is a good starting point for a project, and then you can just modify things as you run through the project. So you get through phase one, you reevaluate phase two. Hopefully you're on track, but sometimes you're not. And so all of that is easy to do. You can do it like this. You can do it in issues. The idea is the organizational principle here. And then Gautam Bhaskaran introduced this, or I introduced the idea of a community master plan in class, and Gautam took it a step further and applied it to his project. So this is knowledge base overviews, their project. So the idea of a community master plan is it shows all the conduits for involvement in the community or the project, or all the conduits for participation. And so, you'll have the different components like the community, the features, the open source aspect, the sustainability, the target audience, and you work out all the components of each of those. So in a community master plan, you have maybe a contributor who comes in and engages with different modules of your community or of your project. So, you might have an education module where you have different components that they can engage with. You have different community where you have different things like webinars, hackathons, virtual conferences. And then that gives you like a kind of an idea of how to guide people as well, or to monitor things going on. Now, the community master plan kind of grows out of this idea of a maturity model in open source software, where you take different aspects of your project plan or your current project and you determine their maturity. So some things are mature, some things are immature, some things are in between, and you then can evaluate them in the context of what level of development they're at. Sometimes maybe that means you need to develop things more. Sometimes that means you need to really kind of evaluate it on terms of being a mature part of the project versus an immature part of the project. This kind of takes this a step further and just allows you to see all of the sort of pathways to involvement and evaluate those independently. And you can also add a maturity model on top of this to say, which parts of these are more mature, which parts do we need to develop more, so forth. And finally, Jacqueline Laville did a really good job on her project. And I introduced the idea of badges and micro-credentials in class. And this is where you learn a skill or you do something and you get a badge. And this is sort of like incentive to do things. So instead of paying people, or we don't really have credentials per se, but you have micro credentials. So you give them a badge, they can put it on LinkedIn or something, and it's a sign that you've participated in the community. Jacqueline applied this to her project, and she had these different badge levels. You register your account and you contribute. So if you make more than one contribution, you get a bronze badge. If you contribute 2 to 5 times, you get a silver badge. If you contribute more than 5 times, but then you also contribute consistently, say like more than once a month, you get a gold badge. And then you also, if you contribute even more and more frequently, then you get a platinum badge. This is not only connecting to micro-credentials, but I also talked about the idea of trust levels that they have in the discourse community. So if you've ever set up a discourse, it's a discussion platform that you can set up for your community. And you have these trust levels where if people post a comment, they get to have more permissions. And then they build permissions and status in that community by contributing more and more and making quality contributions. This kind of combines those two ideas. So I think this is a very good example of how these principles can be applied in different ways. So all the course content is available under a Creative Commons CC BY license. We have various versions of this. We have the 16-week version, which is a spring or fall term thing, and that was taught at the University of Illinois High School. There's the 8-week version, which is the summer version, that's also taught at the University of Illinois High School. And then there's the excerpted version, which is good for asynchronous mentorship, where we just take parts of the different lectures and use them as standalone materials, and that's used in the orthogonal research and education lab. But finally, I want to talk about future topics where I want to cover topics that are relevant and timely, but also want to cover topics that might be relevant to the future of people's endeavors. So one thing that's coming maybe in the future, it's certainly around now, but maybe it'll become more prominent in the future, is project management and open collaboration in virtual environments. So there's been a lot of talk about the metaverse, about spatial computing, XR, VR, what have you. And there are actually platforms where you can meet in the metaverse or in VR, XR, or in spatial computing land. And this is an example from glue.work. This is an application where you have a meeting space here. You have an agile process project board right back here in this room. And then you have the space. This is called Scrum Place in Glue. So this is like Scrum organizations in Agile. And that's the focus here. So you can actually manage groups. You have a large project board. You have a large board where you can put your documents up and review them as a group of avatars. And so there's a lot of interesting stuff at the intersection of virtual environments and project management. So topics like that I'd like to cover in the future and modify the curriculum. That's all I have to tell you about for now. Thank you for paying attention.